Hello everyone. We're taking a look at showing two triangles are congruent by using all of the properties that we've seen so far, and in fact these are the only postulates and theorems we have available to us to use these shortcuts to show that the triangles are congruent. And so we're looking at the side, 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 the side, angle, the angle, side, angle, the angle, angle, side, and the RHL. Those are all the patterns we have available to us. These are not proofs. We're doing a little bit of a practice here just with marking up the diagram and identifying which pattern applies. And then over the next few days we'll be returning back to proofs and using them exclusively as we show the triangles are congruent. So what we're looking at doing here is we're going to use the given information from the given line to mark up the diagram. So you can see there's the given line, there's the proved line. So again, we're not setting this up as a two-column proof. We're just showing that these two triangles are going to be congruent by a certain pattern, and we have to identify what that is. So it's not overly difficult, but it can have some tricky details to keep in mind, as we'll see in a couple of examples here in just a moment. Because with the RHL pattern, the R stands for right triangle, which means your angle has to be a right angle. But it's also possible you could have a right angle showing up in some of these other patterns. That could be a right angle, that could be a right angle, depending on the triangle that we have to work with. So it's really a combination of you have to have a right angle and you have to have a hypotenuse marked. And that isn't the case in these others. Alright, so we'll see that here in just a moment. So let's see what we have so far. We have in number 1, we're told that segment EF is congruent with segment GH. We're told that segment EH is congruent with segment GF. Okay, so that's all the given information. So you can see we've marked up two sets of sides. Is there anything else that we can add that we know for certain? Yes, that shared line between the two, that's your reflexive property of congruency. You are allowed to add that marking. So then, again, a useful technique is to just look at one of the two triangles and look to see where the markings are. Obviously, we have 3 sides marked up, so this is our side pattern. Here's number 2. And we're going to contrast number 2 and number 3 together. Those are both really good to analyze, so we'll make some additional notes in the margin here once we get through marking up these patterns. First, here we have in number 2, we're told that angle S and angle B are right angles. Now, we know right angles are congruent, so that would be a pair of congruent angles. We're also told that segment MS is congruent to segment MB, so I'm giving that the tick mark. Okay, that's all the given information. We want to prove these two triangles are congruent. Is there anything else we can add? Again, there's that shared side, so yes, we can. There it is. So notice here that we do have the right angle. So of course we have a right triangle. Opposite the right angle is the hypotenuse. So notice that we do have a hypotenuse that is marked. And then of course one of the legs. So this is the RHL pattern. Alright, let's take a look at number 3. And again, once we have done that, then we're going to contrast number 3 with number 2, because those are good problems to take a look at. So here in number 3, we are told that segment OG is perpendicular to segment BL. Now remember, perpendicular lines form right angles. So we know we have a right angle, and we typically just draw one, but as there are two triangles, I'll draw a second right angle here as well. So kind of like the previous example where the two triangles had right angles, here the two triangles also have right angles. Now you have to be careful, because when we're talking about perpendicular lines, that does not mean that we have a perpendicular bisector. I mean, maybe it's there, but that's not given to us. We don't know if this segment is also bisecting the segment BL. So we don't know if O is a midpoint. All we know is that it's perpendicular. We have not been told if it's a bisector, so we cannot mark up the lines above and below point O. The second piece of information says that segment OG is bisecting something, but it's bisecting the angle. What angle do we have here? Angle BGL. So take this big angle and bisect it. That means you have two congruent angles here. So that's the only given information we have. So again, is there anything else that we can add to the diagram? Sure, we have this shared side, so a tick mark here on that shared line, that's our reflexive property of congruency. So notice we have a right triangle. And so you might be thinking, well, clearly that must be the RHL pattern like what we saw before. But no, it's not the RHL pattern because the hypotenuse has no markings on it. So we don't have the H part of the RHL pattern. And that's the main point of these two examples side by side. Just because we have a right angle doesn't guarantee it as an RHL pattern, because you must also check the hypotenuse. Here we do have a leg, that is true, that's the leg of a triangle, that's marked. But the hypotenuse is not, so it is not the RHL pattern. Instead, we have two angles that are marked with a side between, so that'll be angle, side, angle. Okay, so take a close look at numbers 2 and 3. Those are good examples to contrast the differences between right triangles. Here in number 4, we are looking at some midpoints. We are told that point U is the midpoint of segment CN. Alright, since that's a midpoint, we know midpoint creates two congruent segments. So tick marks on either side of point U. And then U is also the midpoint of segment PT. So once again, this midpoint is now going to bisect these two segments. And that's what we are given. So is there anything else that we know that we can add to the diagram? We have the vertical angles. We know if angles are vertical angles, then they are congruent. And now we want to identify what pattern that is. So again, if it helps, you can cover up one of the triangles and look at just one triangle. I see two sides that are marked. The angle that is marked is between the two sides, so side, angle, side is the pattern. Alright, let's take a look at number 5 on the next page. Alright, number 5, let's see what we can mark up. Segment PA is congruent with segment PU, and then we're told that segment PC is going to bisect something. What is it bisecting? It's bisecting an angle. Which angle is that? Angle UPA. UPA. Again, remember that middle letter is your vertex. We're talking about the big angle here at P, and this segment PC is cutting that big angle in half. So we have two congruent angles like so. Again, we have a shared side, so we are allowed to mark that up. That's a reflexive property of congruency. And so now what we're looking at doing is identifying where those markings are placed. I have two sides that are marked, and the one angle that is marked is between the two sides, so it's a side angle side pattern. Now, one additional step that we're looking at is completing that congruency statement. So we need to make sure that we get the order of the letters correct. So we're saying triangle PAC, we're going from P to A, which is the side with a single tick mark. So on this other triangle, we want to go from P to U, as that is also the side with a single tick mark. So we'll start with P and then U, so those will be triangle PUC, like so. Here's number 6. On this one, we now have some parallel lines. We're saying that segment QI is parallel to UN, so put the little arrows. Now be very careful, that does not mean they're congruent, so these are not tick marks, you can't think of that. But if you recall, a while back, on a previous section, I'd said anytime you see parallel lines, that's a dead giveaway that we want you to find an angle pair that is congruent, because we've learned in the past that if parallel lines are cut by a transversal, then it forms some angle pairs. So we need an angle that is going to touch the parallel line and is going to touch the transversal. So from this first piece of given information, we can see that the angles that we're looking at are going to be these alternate interior angles. They have to touch the parallel lines, and they have to touch the transversal. So if parallel lines, then those alternate interior angles are congruent. All of that came from just this first piece of information. The second piece of given information says angle Q is congruent with angle N. Is there anything else we can add? Again, the triangles share a common side, so we can put a tick mark here, and that's our reflexive property. So there's a lot of markings here, so this is especially when it's helpful to cover up a triangle and look at just one of those triangles. What we're looking at is we're looking at tick marks, we're looking at the arcs on the angles, but we're not looking at the arrows. That doesn't count. So we have two angles and we have one side, and we ask ourselves, is that side that's marked between the two angles? No, it's not. We can't use that arrow. So it's angle, angle, side. Or if you go backwards, it's side, angle, angle. So that's the pattern we're looking at. Angle, angle, side is what we have. And again, we want that congruency statement. So triangle QUI, QUI. Notice the path I took in naming that triangle. We started at the angle with the double arc. We went along a side with no tick marks, and then we went along a side with a single tick mark. So in the same way on this other triangle on the right, I want to start at the angle with the double arc, which is angle N. Go along the side with no tick mark, so N to I, and then go along the side with the single tick mark, I to U. So we're saying triangle QUI is congruent with triangle NIU. Here's number 7. B is the midpoint of segment AE. So we have tick marks here and here. I have a question for you. Should we also put tick marks here and here on the segment on either side of point B? Is point B a midpoint of DC? The answer is no, we should not. Maybe it is, but that's not what we're given. We are only told that segment AE has the midpoint, so that's the only segment we can mark up. We cannot mark up the other segment. Angle D is congruent with angle C. So those are the two pieces of given information. Is there anything else we can add? We have those vertical angles, don't we? So on either side of point B, vertical angles are congruent. And so now what we want to do is take a look at the pattern in the markings. I see two angles that are marked. The side that is marked is not between the two angles, so it's angle, angle, side. Or you can go backwards, side, angle, angle. And so I label that angle, angle, side. And now the congruent statement for triangle A, B, D. Well, A corresponds to E. Oops, I need my triangle symbol there. There's letter E. So we went A, B, D, so that corresponds to E, B, C. All right, number 8. Angle M is congruent with angle N. Angle MOP, MOP, is congruent with NOQ. Now you'll notice in this particular diagram there are no vertical angles. These previous examples have had vertical angles that we could mark up, or even a shared side that we can mark up with that reflexive property, but here there's no shared side. There's no overlapping side, if you will. There's no vertical angles, so it looks like we don't have anything else to add except this third piece of given information. Point O is the midpoint of PQ, so the midpoint will create two congruent segments. So it's marked up like so. Look at one of those triangles, and we have two sides that are marked. Excuse me, that's two angles, isn't it? Two angles that are marked with a single side. We ask, is that side between the two angles? Nope, it's not. So it's an angle, angle, side pattern like before. And let's write that congruent statement. Don't forget that triangle symbol as we're naming a triangle here. Triangle PMO will be congruent with triangle QNO. And here's our last one. given that segment ST is congruent with segment SV, and given that segment TU is congruent with segment VU, there's our shared side. So by the reflexive property of congruency, we can add tick marks here. So a triple tick mark on segment SU. Well, we clearly have 3 sides marked, so that's our side, side, side pattern. And that was the very first pattern we learned several days back. And now to write the congruent statement, triangle TSU must be congruent with triangle VSU.